All right, this video is going to be about angle proofs, and I think the first thing we want to look at are all the different terms and kind of what they mean. A lot of these things were discussed in the previous unit, or maybe all of them. If I tell you that two angles are complementary, that means they have a sum of 90 degrees. I'm going to use that term. Supplementary, right? A sum of 180 degrees. The linear pair postulate, right? We're talking about taking a line and then arbitrarily breaking it up with a ray or maybe another line, and then the two angles, they form a linear pair, which we know then have a sum of 180 degrees, right? Vertical angles theorem says that if we have vertical angles, right, would be like that angle and that angle, that those angles are congruent. The word bisect means to cut in half, right? We can bisect a segment and we can bisect an angle. If we have an angle and we bisect it, that means we cut it exactly into halves. We cut it into two congruent angles which have the same measure. The angle addition postulate is talking about a situation where you have something like this. We'll call that angle 1 and we'll call that angle 2. The angle addition postulate is just like the segment addition postulate, and it says angle 1 plus angle 2 then equals the total. And so we can use that to talk about the summing up of multiple angles to equal the total. The triangle sum theorem says that if you take any triangle, angle 1, angle 2 plus angle 3 equals 180 degrees. So the sum of interior angles for a triangle is always 180 degrees, no matter if it's an acute triangle like this or an obtuse triangle, it doesn't matter. Perpendicular, we know that symbolically it looks like this, right? It's kind of like an upside down T. If two line segments are perpendicular, that means they have 90 degrees, and actually there are four 90-degree angles formed, right? So if you have a line like this and a line like this and they're perpendicular, then there actually are four 90-degree angles. A straight angle, right, would just look something like this. It's just a line. And we know that a straight angle is a 180-degree turn, right? To go from here and flip it all the way around is 180 degrees of rotation. And then I don't use this a lot, but Mrs. Gimrick does. And it is kind of fun to be like a real mathematician. QED, quod erat demonstratum. And so what that means is that which was to be demonstrated. And really it just indicates the completion of your proof. So at the end of a lot of her proofs, she's going to put QED, which is kind of cool. Okay, so let's go through an example of what an angle proof might look like. Again, this is just one of the examples. So this one, I have the picture drawn for you. It looks like, and then I have a bunch of givens. So given 50 degrees and 100 degrees as labeled. So this angle right here, and so angle EFG is 100 degrees, and then this angle up here is 50 degrees. So I guess if I put two more points, I could have named it something, so whatever. But that angle is 50 and that angle is 100. Given DB bisects angle ADE, right? Angle ADE is this big angle, and it looks like DB bisects it. So that ray bisects that angle, and I know it doesn't look like it. I didn't draw it amazing, but if it says it bisects it, that means it does, and we know what bisect means. Given that angle BDA, this angle, and ADC, that angle are complements. Okay, so we know that this angle and that angle add up to 90, and we know that ADFG are collinear. Okay, so that just means that is a straight line. Even though it might not look like it, I might have actually drawn that line and then maybe I drew these lines afterwards, but that is all one line. All right, so given all of those things, let's find/prove the measure of angle ADC. Angle ADC is this angle right here. So our goal is to find that angle given all those things, and then we want to justify every single step we make. Okay, let's just kind of rock and roll. Let's label things on the picture. So if this is 100, I know that this is 80 degrees. Okay, so let's remind ourselves that a real proof, I would have to rewrite all of those givens. So rewriting all the givens is kind of annoying. So all the givens are right there. All of those things are still true. Okay, and now I know that angle, let's call that angle EFD. EFD, the measure, is 80 degrees. Now, how do I know that? And I'm going to say it's a linear pair. A linear pair. We know that it forms a linear pair with this angle, and we know a linear pair makes 180 degrees, so I know that's 80. Why? Because of linear pairs. Okay, really the linear pair postulate. But lots of times people are just going to say linear pair. Okay, so I know that, and I also know that this is 50 degrees. How do I know that's 50 degrees? Okay, so that measure angle DEF, so the measure of angle DEF is 50 degrees because I know that vertical angle theorem, right? Vertical angles are congruent. So if that's 50, that's 50. All right. Then if this is 50 and this is 80, that's 130, and I know that the triangle sum theorem says then that this angle also must be, it turns out that it's also 50, right? Because 50 plus 80 plus 50 equals 180. So then angle, the measure of angle, this angle is EDF. EDF is also 50 because of the triangle sum. I know that the three angles in a triangle add up to 180 degrees. And I know that, 50 plus 80 plus x equals 180. I just did some algebra to get that, right? So maybe we can justify that with some algebra. Okay, really just a subtraction. Okay, what else do we know? Well, can't we say the angle addition postulate, that this is some big angle, EDE, this angle from here all the way to there? Well, I guess we could say that angle is a linear pair, or we could say the angle addition postulate. I guess it doesn't really matter. If that's 50, that whole thing has to be 130. So that whole thing has to be 130. So that angle is EDE. ADE is 130, and I'm just going to say it another linear pair. Or maybe you could have said angle addition postulate. And then we know that if this is 130, we know the definition of what it means to bisect. So given DB bisects this angle, then we know that this actually has to be 65, and then that has to be 65, because definition of bisect. So now I know the measure of angle ADB is 65 degrees, because of the definition of bisect. So definition of what it means to bisect. Okay, and then lastly, I know that this angle BDA and angle ADC are complements of each other. But if these are complements of each other, that means they add up to 90 degrees, which means if this is 65, this must be 25. Okay, so then the measure of angle of what I want, ADC, equals 25 degrees, and I apologize, it certainly looks bigger than 25 degrees, but that's just how it kind of works. I just didn't draw it very well. And that is the definition of what it means to be a complement. Okay, so I started out with a 50 and the 100, and then I knew some things. I knew 80 because of linear pair. I knew 50 because it's vertical. I knew 50 because of the triangle sum. I knew the whole thing was 130 because of linear pair. I knew I could split the 130 into two congruent pieces because of the definition of what it meant to bisect. And then I knew if this was 65, this had to be 25 because I knew those two angles were complements. And again, all of those were given. And so I worked it down from the given piece of information, and now I have angle ADC, and I know for sure it's correct because I justified every single step, and that's what an angle proof might look like. Okay, this is probably a better example of looking at kind of like a two-column proof of saying these things and then justifying them over here. I know my segment one was a little more sketchy in terms of where I had everything on the paper, but this should help you out get started on angle proofs.